Hi, this is Maggie. In this video, we're going to introduce multiple inheritance, what it is, why we might use it, and the mechanics of using it in Python. If you're unfamiliar with single inheritance, I recommend you watch the single inheritance videos first so you have the background you need to understand multiple inheritance. I'll link the first one here and in the description. Multiple inheritance occurs when a derived class, or child class, has multiple base classes, or parent classes. There are several difficult problems that need to be solved, such as resolving conflicts when the parent classes have fields or methods with the same name. So different object-oriented programming languages handle multiple inheritance in different ways, from banning it outright, to allowing limited versions of inheritance, to allowing it and handling conflicts in different ways. We'll start with an example. The example is going to be very simple, so we can focus on the multiple inheritance ideas. Here are the classes before multiple inheritance. The first class is the calendar item class from Chapter 7 of Objects and Games with Python. A calendar item object is responsible for maintaining one entry in a calendar. It has date, name, and calendar fields, where the calendar field references the calendar object that this calendar item is a part of. That class is not defined in this example. It's just here to provide context. The interesting method is activate, which is the method that is called when the date of the calendar item is the current date. So a calendar item can do something when its date comes up. For example, it might remind you of an appointment, or it might automatically pay a bill or send an email. This is an abstract superclass, so activate has no code. It's intended that it will be overridden in a more specific subclass. The other class is even simpler and is called course. This class represents a college course, and to keep this example very focused, the course class has only two fields, which are both private, course name and description, and just accessor methods to return those values. Both classes have an str method, and the main program simply creates and prints an object of each class. Here is the program running. Now suppose we want to build a system in which we have course sections. A course section is a course that is running on a particular day at a particular time, and it has other properties such as the campus that it's running on, the modality, the faculty member assigned to the course, the number of seats, the students registered for the course, etc. So for example, you might take Intro to Object-Oriented Programming in the fall on the main campus with Professor X, or you might take it in the spring online with Professor Y. A section also has a course name and a description, which are the course name and description of the course that it's a section of. Now, it's possible that the best way to handle this design is by having a section reference the course that it's a section of. But this example is about multiple inheritance, so let's explore what would happen if we made a section subclass of both calendar item and course. If we do that, it means a section object is a calendar item, and a section object is a course, meaning that it can fulfill the responsibilities of both. So its public interface will be the public interface of a calendar item and the public interface of a course. And then it might have its own specialized public interface, including operations such as register and assign faculty member. To start, let's define that so we can see the mechanics. We begin by writing class and then the name of the class, in this case section. Then we put in parentheses the two base class names separated by a comma. The order of the names does make a difference, but we'll get into those details in the next video in which we dive into some of the potential conflicts and how they're resolved in Python. So we can write course, comma, calendar item, and then we'll close parentheses, colon, and here's where we'd put the docstring describing the class. I'll leave that empty for the moment. So this says that section is both a course and a calendar item. Let's say that for fields, we'll have professor, which is a string, and location, a string, and students, a list. Now let's write the init method. You might have noticed a pattern in the init method of the other two classes. First, following the parameters that are used to initialize objects of the class, course name and description for course, and item date, name, and calendar for the calendar item, there is another argument called **kwargs. Second, the first line of each initializer is super, open paren, close paren, dot, init, open paren, **kwargs, close paren, and then the fields are initialized. We'll follow the same pattern in section. We'll take parameters for professor and location, and then we'll take kwargs, and we'll pass kwargs to super init, and then we'll initialize the fields professor and location from parameters, and we'll initialize students to the empty list. Let's write a register method that takes a student name, a string, as a parameter and appends it to the list of students. And then let's write an str method that returns a string composed of superstring concatenated with a new line, professor, a new line, location, a new line, and then the list of students. Now there is one method, activate, that should be overridden in any specialization of calendar item. The activate message would be sent when the datetime for example, of the item comes up. So when it's now. So let's have activate just print a message to go to location for class name. For the location, we'll use the field of the section object. And for the name, we'll get the course name from the course superclass part of the section object by sending the get course name message to self. Now let's create an instance of this object and send it the activate and register messages to see how it works, and then print it out. Now, the first part of that output is from before, the calendar item and course objects. But here, where it says time for class, go to online for intro to OO programming, that's from where we invoked the activate message. Then remember we added a student, me, to the section, and so when we print the section, we see the name of the course description, the professor of a location, and then the list of students. We'll talk about why we don't see the date and name of the calendar item part of the object in the next video. But let's finish up by discussing kwargs. So notice that each init method has its own parameter list, of course, with kwargs at the end. And when we initialize our object of the section class, we pass in parameters for all of the initializers. But instead of passing them in order, we write the name of each parameter equals, and then the parameter value. What this does is create a dictionary of parameters, which are parameter name value pairs. When we invoke the section initializer, the parameters that we see in the init method, professor and location, are taken out of the dictionary and passed in as the first two parameters. When super.init is invoked, the rest of the kwargs dictionary is passed to the superclass initializer. That will be the course initializer because that's the first class listed when we created section. So course name and description are taken out of the dictionary, and then the rest is passed to super, which will not be the superclass of course, but rather the next superclass of section. Again, we'll discuss that more in the next video. But what is left is exactly the parameters needed for calendar item, item date, name, and calendar. If there were anything extra, or if anything were missing, this would crash. kwargs, by the way, is a shortened version of the name keyword arguments. So instead of arguments that we pass in order, we pass them by keyword, which is the name of the formal parameter. So I hope you found this introduction to multiple inheritance in Python helpful. There are some exercises in the description that you can try with this example so you can solidify the concepts and the mechanics in your mind. I recommend you try those, and then try making your own simple multiple inheritance hierarchy. Once you can do that, you're ready to move on.